Guys, we were doing paper mathematics paper B, Thursday 7th January 2021. So we were on question number 19. This will be the final part of this paper from 19 till question 26 we will be solving today. So let's go on. Fx is equal to x cube plus ax minus 3, where a is an integer. X minus 3 is a factor of fx. A part, use the factor theorem to show that a is equal to minus 8. So when you are given x minus 3, always make sure when you're given one factor of an equation, always make it is equal to 0 and find the value of x. And whenever you find this value of x, to prove that this equation is completely divisible by the factor, you need to insert this answer in the equation. Use the factor theorem to show that a is equal to minus 8. So now to show this as well, we will place it in. Now using our calculator, we're gonna solve this. So 3 cubed gives us 27 plus 3a minus 3. So 27 minus 3 gives us 24 plus 3a, and because we are solving this equation and finding a is equal to minus 8, always equal this to 0. So 3a is equal to minus 24 and a is equal to minus 24 divided by 3 gives us minus 8. Hence, proved. We have proved our part A. Now, given that fx is equal to x minus 3 qx, where qx is a quadratic expression in x, find qx. Now, looking back to the first part, this being a factor of this means this can be completely divided by this, and we kind of proved it over here as well. So now when you multiply this with something, you get this equation. Now we have to find that something, which is also known as qx. So whatever we multiply 3 minus x minus 3 with, we have to get this quadratic equation. And what qx is, it's also a quadratic equation. So now that we know the value of a and we know what to do, because we know the original thing and we want to know what we have to find after by which we multiply x minus 3 to find the equation, and obviously we divide the original equation by the factor. So first we will write the equation plus or minus 8x minus 3, and now we have to divide this equation with our known factor, which is x minus 3. So now how we do this? First, the main thing we need to do is keep these two same. So what do we do to make x cube? We multiply it by x square. So by multiplying x square with this whole equation, we get x square minus 3x square. Now next step we do, change the signs immediately and cancel out this and solve the other rest, which gives us minus 8 minus 8x plus 3x square. Now again we will multiply it by minus 8, we get minus 8x plus 24. Change the signs, 3x square minus 24. Now plus 3x gives us 3x square minus 9x. Change the signs. So 9x minus 24, you can carry that thing down as well, which gives us minus 27 as a whole. So we'll go with plus 9x minus 27. Change the signs, we get an equal to 0. And now this equation we have over here, simplify, which gives us this quadratic when minus 8 plus 9 equals 1, 3x over here and x square in the front. So qx is equal to, or quadratic equation, which is x square plus 3x plus 1. Question number 20. Here's the diagram, and the diagram shows triangle ABC showing all your construction lines. Construct the perpendicular bisector of AB. Okay, so what is a perpendicular bisector? Perpendicular means always to 90 degrees. So AB, perpendicular to AB, would mean any line which is at 90 degrees to AB. But what a bisector does is divide this line into half as well. So the perpendicular bisector is a line which is perpendicular to AB and it cuts through the center of AB. So for this part you will need your compass, through which you draw circles, of course. And the rules is the radius of this compass should be greater than half of AB. It can be any value you want. Yes, so over here we'll just keep it till here. And now I'll shorten the screen a little bit. Okay, so keeping it at one point, let's take point A first. Draw an arc overhead. To make sure you don't get waste of space, try to keep it more than the radius, but keep it close so it doesn't go out of the page. Draw an arc overhead over here, like this. Once you've done that, also try to make it a bit longer. Yeah. Now do the same with the point B and try to cut that arc. Here we have a intersection point. Now using the same point, try to make an arc at the bottom as well. With this, make sure to keep the radius same, and using A, again cut that arc. Now we have two intersection points. Now using a pencil and a ruler, we join these two parts. And our perpendicular bisector is this line, and we can clearly see that it's been divided by half. And it would be preferable if you extend this line till the end, because our next parts will be asking us about that. Okay, the diagram shows triangle ABC. Okay, we have done part A, we're doing part B now. The bisector of ACB. Okay, now we did the perpendicular bisector of AB, but now we are doing the simple bisector of ACB, and by ACB we mean an angle bisector, because ACB is this angle over here. So what to do now? This bisector divides AC and this angle actually into two equal halves, and it is also a straight line. To make that, keep the radius of your compass less than the radius. You can see over here, keep it less than the radius. Put it on the angle, make one cut on this half on this line and one cut on this line. Now using the same radius, place the needle on the place you cut and draw an arc over here, and placing it on the other side, cut that arc over here. Simple. Now using our pencil and ruler, we'll join this, extend it till the end, and here we have, or angle bisector from ACB. Okay. The region R consists of all points inside the triangle that are closer to A than to B and closer to BC than to AC. Show by shading the region R, label the region R. Okay, so first we'll just find which point is which. Okay. Closer to A than to B. Any point in this area. But they also say closer to BC than to AC. So BC than to AC. So we know that from closer to BC than to AC, it's this area. What comes in common between them? Obviously this area, this center area. Also we can see that it's closer to A than to B, and it's closer to BC than to AC. So we'll just shade it whatever way you like, but make sure it's a little prominent. Or don't try to waste your time like I am, sorry, and just label the region R. There we are. So we're done with question number 20 as well. Question 21. Okay. The diagram shows a circle ABCDE with center O. AC is the diameter of the circle. AB is parallel to ED. So this question is about circles, and it will require the drawing of imaginary lines as well. So here first we'll read the question. So we are given the angles, both of them over here as well. Giving your reasons, find the size of ACB. So where's ACB? This angle, this theta over here is ACB. Okay. So first of all, let's find our unknown sides. And what can we find? We can see that this is the diameter, and whenever there's a diameter and another point is touching the circumference, this always makes a 90-degree triangle. So we know that this is a 90 degrees triangle because the diameter and one point at the circumference makes a right angle triangle. Whenever a question asks you to give your reasons, make sure you write them. Okay, so this part, it has all four sides touching the circumference. So we can use the cyclic chord formula to find these two angles. What is a cyclic chord? What is a cyclic chord? It is a quadrilateral in a circle with all its ends touching the circumference. And what is the formula? Opposite ends equal 180 degrees. So if this is 120, this is 180 minus 120, which gives us 60 degrees. And this opposite to this, so 80 plus x is equal to 180. So if this is 80, this will be 100 degrees. Why? Because it's a cyclic quadrilateral. Now, we can see these two lines, this one and this one, is parallel. So we know what an adjacent angle is. So we'll just extend this line. This line is a continuation of this, and it is straight. Because it's freehand, it doesn't look like it. And now you know DEA is equal to BA, let's name it X, BAX, because they're alternate, or you can say adjacent angles. So this will be 100 degrees as well, because these two lines are parallel and they have one common straight line. So both of these angles will be same. Now we know that an angle on a straight line is 180 degrees. So we have two sides. This is one straight line, and we have 100 degrees over here, we have 60 degrees over here. So to make a 180 degrees, we have a 20 degrees over here. So now complete angle sum in one triangle is 180 degrees. So we have, or 90 degrees. we have our 20 degrees and we have a theta which equals 180 degrees. So theta plus 110 is equals to 180. So theta will equal 70 degrees, and that is our answer. If you don't understand anything or you think I should improve on some aspects, please let me know in the comments. So ACB will be 70 degrees right over here. I haven't written the entire solution of these all angles, but you should not risk it, and you should write everything, because the examiner won't be able to understand what you did, or he'll think you are unclear. Question number 22. The diagram above shows a right circular cone S with the base diameter 20 cm and the height 20 cm. Calculate the volume in centimeter cube to three significant figures of S. Okay, so first we'll write the formula of volume of a cone, which is 1 divided by 3 multiplied by pi r square into height. Pi r square is the formula of area of the circle, and height, h, is the height over here, multiplied by 1 over 3, which will give it the decreasing volume. So we have both of them, except we don't have the radius, but we know how to calculate a radius out of a diameter, and the radius is a half of a diameter, so it will be 10 centimeters. So 1 over 3, all you have to do is substitute the equation. Pi into 100 square multiplied by 20 will be, we will use our calculator. And we get to three significant figures we have to write, so we will write 209 4 000. That's it, 209 000. So we will tally the formula again. Pi r square h, oh wait, I'm sorry, this was 10 square, so this will remove these two zeros. Okay, it's 2090 actually, centimeter cubed, because 10 centimeter square is 100. I was taking at 10,000, sorry. Okay, write it over here, centimeter cubed. Now we have another part, this equation. The shape B is formed from cone S by cutting S parallel to its base and removing cone A as shown in the diagram above. Okay, so now the height of B is 10 centimeters, which automatically tells us the height of this will be 10 centimeters as well, because the whole cone was 20 centimeters in height. And the height of B is 10 centimeters. Okay, calculate the volume in centimeter cubed of to three significant figures of B. So what we need to do is to find the volume of this cone, and then subtract it from the volume of the whole cone, the complete cone, which was 2090 centimeter cubed. So now we will take help from a little trigonometry. This is 10 centimeters, and now we don't know what this is. Here is an angle, so whatever angle this is, this angle will be the same. Why? Because both of them are similar. This complete S and this part, both are similar cones, similar figures, so this angle will be the same as this angle, and this angle will be the same as this angle. So what we do, we simply find out this angle over here by using simple trigonometry and by using our complete diagram. This was 10 centimeters and this was 20. So now using our tan rule, like the SOHCAHTOA we did, so tan theta is equal to 20 over 10, and hence tan inverse 2 over 1, which is 2, because 20 over 10 is 2. So tan inverse 2 gives us an angle of 63.4 degrees here. Now we have this, and now we have the tan as well, this height. So all we need to do is find the radius, using which we will find the volume of this cone. How to find the radius? Use the exact formula we just did. Tan 63.4 is equal to opposite, because now the opposite is 10 centimeters instead of 20, divided by adjacent, which is x. We don't have the radius, that's what we are finding. Tan 63.4, we have the angle already. Okay, so now x is equal to 10 divided by tan 63.4, because x moves over there and tan moves over here as division. So now, using our calculator, we get 5 centimeters, 5.00, which gives us 5 centimeters is the radius. So now we need to find the volume of the smaller cone, which was 1 over 3 into pi into 5 square into height, and we need to subtract this from the volume of the entire cone to get the final volume. So first we will find the initial volume of the small cone, 1 over 3 into 25 pi into 10, which gives us 261.799. Using the accurate value subtracted, we'll get 1828.2, but they asked you to give it in 3 significant figures, so we will use 1830 centimeter cubed for this. So using our entire cone, we figured out the value of this angle using trigonometry, which was the same as this, and using this, again using the same trigonometric formula, we found the radius, and using the radius figured out the volume for the small cone, and we subtracted this volume from the volume of the total cone to get the volume of B. So we are done with question number 22. Question number 23 is about histograms. The incomplete histogram and the incomplete table give information about the daily mean temperature for 184 days measured at Heathrow. Okay, none of the daily mean temperatures were less than 5 degrees C, and all the daily mean temperatures were less than 25 degrees C. Okay, they were less than 5 degrees C. Okay, so we see the graph over here, frequency density and daily mean temperature in T degrees C's. Okay, so we have a table below, daily mean temperature and the number of days. Complete the histogram and table. Now you should notice one thing, we have daily mean temperature, which is given over here in the graph, but here for the y-axis we have number of days, and instead over here we have frequency density. Now don't mistake this thing is equal to this, because it is not. To find the frequency density, you will need to add 2 different labels for your understanding only. One is known as class width, and the second you will use to find the frequency density. Now what is class width? It is actually the difference of these 2 numbers, of how big it is actually. So from 5 to 10, class width is 5. From 10 to 15, the class width is 5. 15 to 17, the class width is 2. And from 17 to 25, the class width is of 8. Simply subtract these and these numbers to get this class width. Okay. So now to find the frequency density, all you need to do is divide the number, the y-axis value, or over here the number of days, with the class width, and over here we get 4. 80 divided by 5, we get 16, I guess. Yeah. And from 15 to 17, we have a graph over here. From 15 to 17, the frequency density over here, and 17 to 25, we will be figuring it out. Now, using the frequency density value of 5 to 10, we will first figure out the values of the y-axis. So over here, from 5 to 10, over here, this is 4. So from 0 to 4, if this is 4, 2 blocks make 1. 1, 2, 3, 4, and so 2 blocks make 5. So using 2 blocks, we'll just keep on adding 5 here till 20. So now we know the numbers over here. So now we can easily find 15 to 17, which is over here. So this is 17.5. So 16, 17, and 18. So the frequency density of 15 to 17 we just saw is 18. And now to find the number of days, we will multiply frequency density and class width, which gives us 36. Now, from 17 to 25, we have a class width of 8. And now what we will do? Yeah, so what we will do over here, we know that the number of days were 184. So after 20, 80, and 36, how many days are left? Simply 184 minus 36 minus 80 minus 20. What we get is 136. 184 minus 136, which gives us 48 days. Or is it 48 or? Yeah, 48 days. And now we have 48 days, we have the class width as 8, and now we can find the frequency density by dividing them both, which is 6. Now, complete the histogram. So from 10 to 15, we have a frequency density of 16. Over here, this till here is 16. So you should use a pencil to draw this, because if any mistake happens, you should be able to cover it. Make a graph till 16. Now we have till 15 till 17. Now 17 till 25, we have a frequency density of 6. We just calculated it. And 6 from 2 blocks above 5 is 6, and till 25, this is 25. Don't exceed, don't be lesser than the given amount, and it should be exact till 25. Now we're done with question number 23 as well. Okay, moving on to question number 24. Okay, the functions f and g are defined as the given. Find fg6. Now to do this, you need to divide this thing into two parts. First, make it g6, remove the f first. Calculate g6, and then the value of g6 you put it in f function. So I'll just calculate it. What is g6? First, okay, start calculating from the right side. That's the simplest example I can give. So g of 6 is, in place of x, just substitute 6, which gives us a total of 34. Now f of g6, which means 34, you have to calculate, which gives us, place 34 in place of x, subtract 3, you have 31. So our answer is 31 over here. 2 marks guaranteed. The function h is defined as follows. Show that hx is equal to x square minus 6x plus 7, which is a quadratic equation. So now the function h is defined as this is equal to g f of x. Now this is hx is equal to g f of x. So now what we do, the same method we used of FG6, all you need to do is calculate gf of x, and it should be equal, it should automatically be equal to h of x, and whatever answer you get, it should match h of x equation given here. So we'll just do that. F of x is, we don't need to calculate, we already have. All we need to do is put this value in g of x. So in place of x, g of f of x, we need to place in the value of f of x, which is this. Now open this using second identity, which is x square minus 6x plus 9, out of brackets it's minus 2. Simplify this whole, x square minus 6x plus 7. Does it match? Yes, it does. So we'll just write hence proved, and we're done with this part. The domain of h is x of x is greater than or equal to n. The inverse of h is h power minus 1. State the least value of n for which h of minus 1 is a function. So over here we cannot take the square value, so we will be taking this x is equal to 3. We will equal x is equal to 3, x minus 3 equals to 1, so x we get is 3, and n is will be equal to 3. Part D. For this value of n, find h inverse of x. Okay, so for h inverse of x, we have been given it over here. Now what to do over here? For this part, what we do, I've written it already over here, so I don't have to write it again. We have h power inverse of x, which we already know. We solved it over here. All you need to do is first write it over here. Now instead of h inverse, just substitute this value by x, and these values you can substitute by y. Instead of x, write y. And now, or just wait, instead of x over here you can write y, and instead of the y's here, just substitute with x, because we're finding it in x. So instead of writing the open function, write it in this way. Through this it will be easier to open up the square, and I will be doing it over here. How? Move to the other side, which makes it x plus 2, and take a square root on both sides, which opens the square automatically. Now we have y plus 2 in a square and root and x minus 3 outside, and now we can easily make x the subject. How? Move 3 to the other side, so y plus 2 plus 3. So here is your inverse equation, and you can just simply write it over here, y plus 2 plus 3. Pardon my handwriting, it's just like this. Okay, so always remember this value is always y, and you have to make x the subject, so you can get the value of in y's. Okay, we're done with question number 24. Moving on to the second last question of this paper. Okay, 3D figures. Diagram shows a solid pyramid, right pyramid ABCDE with base square ABCD on a horizontal plane. The vertex is vertically above the center of the base. So we know that all the sides are same and the base is square, and point E over here, if you draw a straight line over here, it will point at the center of this square. Okay, midpoint M, M is the midpoint of CE. What is CE is here, so M is the midpoint, and N is midpoint of BE, and is over here. Given that AN plus NM is equal to X meters, calculate the value to two significant figures of X. So we have 34 meters over here, which means 34 here. We have 32.3 over here, which means 32.3 on all sides. It's the same length. Okay, so now what we need to do is to find the lengths of these two, and we'll just equal them to X to find the value. We'll just add them both to find the value of X. So right now what we will do is use the cosine rule. What is the cosine rule? Okay, using this triangle, I'll just write it over here. We'll just label this side A, we'll just label this side B, we'll just label this side C. Okay, so the formula is A square equals B square plus C square minus 2 into A into B cos angle E. Just memorize this formula. So this is A side A square is equals to B side B square plus side C square minus 2 times B into C multiplied by cos E. I hope you got it from my gestures. Okay, so let's just solve this equation. Here's 34 square equals 32.3 square plus 32.3 square minus 2 times 32.3 into 32.3 cos unknown cos theta. Now all you need to do is type or just simplify this whole equation by just typing it in your calculator. Make sure you put everything over here, and for now I will not be taking it to solving it correctly. So I just typed it on my calculator. It gives us 58.44 degrees. So we have this angle as 58.44 degrees. Now we have every side over here, and using this it should be extremely simple for us to find this length. How are we gonna do that? Okay, what we will do is we know that N is the midpoint of BE, so we know the length of this area is 32.3 divided by 2, and what it is 16.15. So we know the length here, we know the angle over here, and we should first find the 16.15 over here as well. Now we have this length, we have this length, we have this angle, we have this length, we have this complete length. All we need to do is find this length in the center, and we will use the same cosine rule formula we did before, because we have the angle and we only don't have this side. We have this side and we have this side. So because it is unknown, we'll just name that side X. X square equals 32.3 square plus 16.15 square minus 2, 32.3 into 16.5 cos, because we know the value, we have this. Now just simply calculate it on your calculator and we get 29 meters. Okay, here we have our length of AN as 29 meters. So now all we are left with is the length of this, and this is actually pretty easy because we have the length of EC, which is 16.15, because the length of this is same as this entire, and the midpoint obviously will be the same. So we have 16.15 here, 16.15 over here. All we need to do is find here this side, and to do this we know make an imaginary rectangle like this, or we'll just cut it at some place and the right angle triangle over here. Now what we do, this angle is equal to this angle and it is 58.44, and now using our cos, using adjacent over hypotenuse, because so ka means CAH and C cos is equals to adjacent divided by hypotenuse. Hypotenuse is 16.15 as we calculated before, and what happens next, cos of 58.44 equals adjacent, we don't know, over hypotenuse. X will give us 16.15 times cos 58.44, 8.453 meters. Now this line is 8.453 centimeters, and this line and this line are parallel. So what if we subtracted this part from the complete line, so we would get this part, and that's what we're gonna do. We know this whole line is 34, so 34 subtracted 8.453, we get 25.5. to 3 significant figures, but to 2 significant figures it's 26 meters. Now what we do, we have our AN and we have our NM. All we need to do is add both of them. So AN was 29 and NM was 26, which gives us 55, and our length is 55 meters total. So we're done with some part of, we're done with question number 25. Let me just confirm. No. So we have a part B as well. Calculate the size to the nearest degree of angle BAN. Let's look at the diagram again. BAN, this angle. Now how we found out, how we will find out BAN over here is by first finding out this complete angle, or we can simply use the cosine rule of 16.15 square equals to 29 square plus 34 square cos x. That's what we will do. Just let me write it over here. 16.15 square equals 29 square plus 34 square minus 2 into 29 into 34 cos x, the cos theta. Now again, I will not be going in too much detail in solving this part all, and I will simply be writing this answer over here, which is 28.29, but to the nearest degree we will round it off, so 28.3 is our first rounding off, but we will simply write it as 28.3 or 28 degrees. And instead of using an equal mark, when you're rounding off anything, you should use this, which means an estimation, and 28 degrees is our angle. So we're done with question number 25. Now last question, question 26. A particle P is moving along a straight line at time t seconds. The displacement s meters of P from a fixed point O on the line is given by the following equation. At time t seconds where t is 0, P comes to instantaneous rest. Find the exact value of t. Now this is a differentiation question. Whenever you see this, you can like easily identify this as a differentiation question by the use of a particle P and this equation. You can see square and cube. Now find the value of t when where t is greater than 0, P comes to instantaneous rest. So first you're going to differentiate s. So ds over dt, because it's speed to time. How you differentiate? Now the power over here, you have to multiply this power to the coefficient over here and then place minus 1 on this power. So what happens when you multiply 2 to 5, you get 10 t, and when you subtract 1 from 2, you get 1, so we don't have to write it, minus 3 multiplied by the coefficient of t is 1, so 3 multiplied by 1 is 3, and 1 subtracted from 3 gives us a square. Differentiation is very simple. Now when t is greater than 0, P comes to instantaneous rest. Okay, so for rest, whenever there's a mention of rest, you have to equal this whole thing to 0 and find the value of t. So 3t square is equals to 10t. We moved 3t square to the other side. Now t, when you move it over there, it simplifies with t square to give us simple t, and the value of t is 10 over 3. So we'll just write it over here, 10 over 3. Now for part B, find the total distance traveled by the particle between t is equal to 0 and p is equal to 5. So to confirm this part, first we will need to see whether the particle has come back to its original position. Now we're given the time is equal to 0 and t is equal to 5. So obviously when you input 0 over here, the answer is always 0. But now to see if it comes back to its original position after 5 seconds, t is equal to 5. Now when we substitute 5 in this equation, it should be 0. So that would mean it came back to its original position, and now we will do that because t is equal to 0 and t is equal to 5. So 5 into 5 square minus 5 cubed, it gives us, let me check my calculator, it gives us 0, which means that the particle is traveling back to its original position. Now To find the distance traveled by particle between t is equal to 0 and t is equal to 5, which means the double the distance, we have the value of t over here. Now all we need to do is substitute 10 over 3 in s, which gives us 10 over 3 square minus 10 over 3 whole cubed. And now we will simply type this in our calculator as well. And it gives us 18.52. And so here we have the total distance traveled till there to its destination and back, and this actually isn't it. And let me just check if I did any mistake, because the answer, no, actually it's fine. So now all you need to do is multiply this by 2 to find the total distance. Try to keep it in a fraction, and in a fraction, if we solve it, it is 27. Now we have found out the distance traveled to its destination and the distance traveled back, because 18.52, I think I miscalculated it before. 18.52 means to its destination only, because when we put in 5 in the question, it gave us 0. It means it came back to its original position as well. So we will multiply the time by 2, but the distance by 2, and over here we can write it in fractions. This is the total distance traveled. Okay, we're done with the paper 2021 mathematics.